Welcome. Actually every year at this moment, I'm very excited, to get the opportunity to support. I think it's a relative small number of students to work for a higher level of USNCO, the national exam, right? So I want to, briefly introduce, this prep class, the scope, the style, the contents, the difficulty, and then feel free to, stop me if you have any question, okay? Since, it's a relatively small class, feel free to just jump in and you don't have to type. But if you prefer to type your questions, it's fine. I will, check the chat, okay? Great. First, since, we are working on USNCO, we definitely should know, the exam, right? You all know the USNCO, all of the multiple choices questions are relatively standard. That means they assess you 10 topics every year, right? So there are 6 multiple choice questions in each topic. And some of the questions are highly, repeatable. So which means it was assessed every year pretty much, right? I call learning objective because, I summarize, a full list of learning objective. I believe many of you already saw my list. I will share that with you again later. But since there are only 6 multiple choice questions under each topic, there are definitely more than 6 learning objectives, right? So that means some of the learning objectives will be assessed in a rotating basis. Maybe it was assessed this year, but it might not be assessed in the following years, right? But when we do the preparation, we definitely need to go through all of them, right? Because we cannot say, oh, I'm lucky, something I don't know will not be assessed, right? And also, you probably realize for each answer choice, A, B, C, D, there's only one correct answer, but all of the other 3 are here for a particular reason. And typically, it will be the results of a specific mistake you might make, right? So that means they are not, randomly, make up some wrong answer choices there, right? They already think about what kind of mistake you might make and then lead you to a wrong answer. And typically, if this is the case, unless you figure out the mistake, you cannot really find the mistake by reviewing, because you will directly follow your initial idea and then double check your calculation or your thinking, and you get the same, wrong answer, right? So I think this is one of the challenges of the USNCO, both the local and the national part 1. Yeah, and also the last one, I think you can clearly see there's a significant increasement in the difficulty in the most recent years, both in the local and in the national part 1, right? And there are some very new type of questions, right? We never saw them before. We probably never expect them before, right? Those questions are really assessing your conceptual understanding, your solid background in math, and your problem solving skills, right? I think it is a combination of multiple skills. So this is the characters of the MCQ questions. Next, I would like to briefly compare the national part 1 versus local exam. First, the time is shorter, right? 90 minutes. I know the local exam is not necessary to be 110 minutes because in different areas, you may use different strategy. But in general, right, you can see the same amount of questions, but 20 minutes less is a significant decreasement. So you have to use your time wisely because a hard question is 1 point, an easy question is also 1 point, right? There are many more complicated computations in the national exam, which requires you to have a solid background in pre-calculus. When I say pre-calculus is typically the USNCO will not ask you to use calculus knowledge or skills to solve problems. Typically, in most, I would say 99.9%, right? There might be 1 or 2 questions in the past 10 years. If you have the calculus background, it might be helpful, but even you don't have, you can still solve it, right? You will see a lot of examples later, okay? And then there are a bunch of more advanced conceptual understanding. That means the contents are getting much deeper, especially in thermodynamics, in kinetics, in equilibrium and also in electrochemistry, right? Lastly, there are more advanced, harder descriptive chemistry, basically the reactions, right? Properties of elements, compounds, and also organic chemistry, which means you have to learn more. I know, organic chemistry and descriptive is always the two hot topics for most of you because they are beyond the scope of AP chemistry, right? But for the national, you cannot say, oh, I can simply skip that, right? That would be very hard for you. And it will make you less competitive. For example, iodometry, it was assessed in the most recent year for local and national Power 1, right? This is obviously a more advanced topic. And in organic chemistry, the new direction is to assess the relationship, your understanding about structures and the reactivities, because we always say reactivities are determined by structures, right? And how they are related. And also some spectroscopy, aldo condensation reactions, acetyl, hemiacetyl, so kind of weird names. They are not common. They are not even common in the first year of college level organic chemistry, right? They are kind of in the second semester of organic chemistry. And also they are not some typical reactions, right? But they were in the USNCO, especially in the national, right? In 2021, the USNCO had some kind of good data comparison between the local exam and the national Power 1. Because that year, everything was online, right? It's the kind of the peak of the pandemic. So as you can see from the left figure, there are, I don't know how many students in total, probably several thousand students took the virtual local exam. So this is why the ACS, the USNCO headquarters, got some statistics, right? In the other years, because the local exam was distributed to each local section, right? So typically we don't have the data. So you can clearly see if you pure guess, the average is supposed to be 15 points, right? 1/4 times 60, right? But the mean in 2021 local exam, the LSE is local section exam, is about 31, right? So 50%. And then the national Power 1 in 2021, the mean is also 31. But it doesn't mean they have the same difficulty, right? Don't forget, the national exam takers are actually the top students from the local exam, right? So actually, there is a significant, elevation of the difficulty. So according to the test writer, so if we compare the students in the right side, so those around 1,000 students, obviously they all took the local exam. So their average performance in the local and the national, there are a 12 points difference. The USNCO national Power 1 is 12 points harder than the local section exam, which means averagely they score 12 points lower than their performance in the local exam. Think about if we follow the average, now say if you score in 50 in the local, then you may expect 40 or even lower in the national, right? Although this is not always true for everyone, right? But averagely, you should expect such a difference, right?
So you're saying that the average score for people, so like the average local score for people who qualified for nationals is 42 approximately.
Yeah, I think so. Yeah, you're right. That's a good point. Yeah, I think so. And also, if you have a look at the highest scores, right? National Power 1, the highest, it seems like it's 59, right? 59. And there are maybe 1 or 2 students. I think it's about 2 students. So which means if you score higher than 50, the Power 1 is already pretty much in the top 20, right? In Power 1, if we only consider Power 1. So if you score higher than 50, you are already the top 20 student in the whole nation, right? And also, how are the national awards determined? We never get any official information or conclusion from the website, but we all believe there are some, formula used by the USNCO. So before 2021, the equations are here. You guys can have a look. It's pretty interesting. They use, a very different way to determine the honors, high honors, and the study camp, right? In part one, the original score is 60. After you multiply by 1.25, it is 75 points. Part two, the original score is 100 points, right? Part three, the original score is 50 points. So after times 0.5, it gives you 25. So in total, it's 200 points. But obviously, not everyone's part 1, 2, 3 are counted, right? When they determine the honor, high honor, and the study camp. So this is also why every year, the number of students who got an honor vary a little bit. Sometimes it's 146, sometimes it's 151, but it's around, 150 students because they need to find a cutoff, right? But it's not, the cutoff may not give you a perfect number of 150 students, right? So starting from 2021, it seems like there are some changes. So in the past, if your goal is only honors, you only need to take care of your part 1, right? But now it seems like both part 1 and part 2 will determine the honor and the high honor. So I feel I have some kind of internal pictures from the test writers, but due to some limitation, I cannot, directly put here to show you guys. But I believe there is a cutoff for part 1. There is also a cutoff for part 2. So that means if you score pretty high in part 1 or very low in part 2, you might disqualify to get the honors. That's possible.
So if you got like a decent score in let's say you got a decent score in both part 1 and part 2 and you got into honors, so then what would your part 1 score approximately be?
Yeah, I will talk about that later. So according to the test writer, 30 points in the national part 1 is the average. Actually, it's pretty good, considering the difficulty of the test, right? And 40 out of 60 should be competitive for honors. And based on the data in 2021, you should score at least 55 points in part 2 to get the honors. Even your part 1 is much higher than 40. You still have a kind of cutoff in part 2. Does this make sense to you guys? I think the general idea is clear, right? 45 is next level. It will be competitive for high honors, but obviously there is also a cutoff for your part 2, right? To get it into the high honor. And 50, as I mentioned, from the part 1 itself is already in the top 20, right? So it's competitive for the study camp.
So if I got a 40 plus 55, that would probably be an honor?
Yeah.
Okay.
That is in 2021. Obviously, the cutoff, varies every year, right? So it's hard for us to use this in 2023 or in the following years. But if you try the 2021, you should get a general idea about how hard it is.
Okay, got it.
Mm-hmm. No problem. So my strategies for this class, first, I want to focus on problem solving. The main goal is to boost your performance in the exams, both in part 1, 2, and 3. But I probably will spend 70% to talk about part 1 to help you prepare part 1, because I think that is the first step, right? I believe, preparing part 1 will also be helpful for you to prepare part 2. They're not conflicting with each other, right? So about 20% of time will be used for part 2. And then I will use, some time to give you some, introduction about how to work on part 3. But to be honest, part 3 is lab, right? Is lab. So we can talk about that because the majority of the points are still related to your writing. It's not really related to how well you finish the labs. Okay. So that means I'm going to make some changes. This schedule might be different from what I posted in my website. I want to focus on problem solving. And also I want to provide a very detailed profounding, that means very deep and educational explanations to the most recent years of USNCO, at least the national part 1. If we have more time, we can also talk about the part 2. But for part 2, the easy thing is they have a relative detailed, answer key, right? So that means, we definitely can further extend and can further explain, but part 1 will be harder for you to prepare independently, right? Even we already provided all of the detailed annotations, but still reading the annotations can help you, but sometimes it may not give you the very insightful understanding. That is, my work. I want to help you guys, promote your deep understanding here. So for that means for non-computation based questions, you understand each answer choice, why this one is right, why the other 3 are incorrect. For computation questions, you know how to use your math to solve a problem. And after that, you can also stand in a higher position to look down this question and fully understand what is the principle of the question. So I want to make this class a little bit more interactive. So I really appreciate, your active participation. You ask questions, you answer questions as well. So we'll combine, class discussion, text interaction, and some polls, and also probably some Kahoot games to make the class more interactive and you guys are more engaged. Because I taught 2 years, pretty much 2 years, virtual classes in 2021 and in 2022. It was tough, right? I believe most of you probably also suffered from this process with a certain period of time. So it's challenging, right? So unfortunately, we are a virtual class, so it's hard for you to pay full attention for 90 minutes all the time, right? So this is why I want to make it more interactive. Please also remind yourself, right, to focus a little bit more, try your best. Lastly, I want to provide 3 mock exams. 2 of them will be part 1 mocks, and the last one will be part 2 mocks. So they will be provided after the 1st, the 3rd, and the 6th sessions respectively, which means after the class today, I will give you a link in Google Classroom. There will be a mock test in a Google survey, style. You definitely need to get the scratch paper. You need to write down your work, and then but when you submit, you just submit in the Google form. Okay. It will be 30 multiple choice questions. I expect you to finish in 50 minutes, but I think the time is not that critical for our first trial. My goal is for you to finish it first. Okay, try your best to finish it. But if you want to time yourself, I would say 50 minutes is a kind of fair timing. So typically my marks are not novel as the USNCO national, but it will be a little bit more challenging than the questions. So which means after you practice those questions and then you further work on my marks, and then if you can get most of them, I would say you got a pretty good understanding when you work on the questions initially. Right?
Can I ask, is there any specific year that I should avoid doing those mock exams?
No. For example, my first mock will be based on National 2021. That is something I'm going to discuss with you today. And then you are supposed, that's my next, I will talk about that later.
Okay.
So you don't have to avoid anything. You can do whatever you like.
Yeah, for like on my own practice, I can do.
Yeah. So
the
you
mock
can
exam
practice any year you like. Yeah. So even for my mock, I'm not using the same questions. I want you to finish those questions first, and then you try my mock.
Oh, okay, got it.
Yeah. Because my mocks are typically a little bit more challenging, and there will be a deeper conceptual understanding or more complicated computations involved.
Okay.
Okay, you guys all know the 10 topics, right? We don't need to talk about that. Typically, the difficulty of the national part 1 is like this. There will be 1 to 2 easy questions. That means, the average will be relatively high, and there will be 3 to 4 medium questions. There will be 1 to 2 hard questions. So my focus will be the easier and medium questions. That means if you don't make silly mistakes, you should be able to get 40 out of 60, right? And 40 actually is pretty competitive for you to be in the honors, awards, right? And it doesn't mean you need to skip the hard questions, right? But it will not be my focus. You definitely will talk about some of them, but if you feel that's too hard for you to reach, it's totally fine, right? It's totally fine. And combining some reasonable guess, sometimes choosing between one of the two answer choices, I believe you can get some of them, right? Even you are not quite sure about what is the correct answer.
Dr. Chen,
Yeah.
we'll still receive some training on the hard questions, right?
Oh yeah, that for sure.
Because when I did the mock 2015 to 2020, I got scores of about 40. So
that's pretty good. That's pretty good. And I would say get 40 doesn't mean you fully understand that 40 for most of the cases. So what I want to do is to deepen your understanding of that 40, and hopefully I can also help you to work on the other 20. Okay. So who will be benefiting the most from the class? I hope everyone will get a good benefit, but I still want to emphasize who will benefit the most. First, you should practice the national part 1 and 2 like real exams, right? That means you time yourself, you give yourself 90 minutes, you fully focus, you try to finish in a one-time block of 90 minutes. Right now, oh, I finished 6 today, I try another 6 tomorrow. That doesn't work, right? You need to focus, time yourself, give yourself, I would say it's more like a struggle feeling. You need to practice the struggling, right? Because when you take the national exam in the real, situation, you will be struggling. Trust me, right? Because you feel, wow, the questions are so hard, right? And I'm not sure. I'm not sure a lot of questions. So you need to practice that. That will give you, the best sense how you can score higher in the real national. And for any computation-based questions, I need you to show your forework. So I posted all of the single column national part 1 test paper in Google Classroom. I strongly recommend you print those test paper and show your work in the right side or in the left side, the blank side, right? So I emphasize computation-based questions for 2 reasons. First, it's good for you to review. Secondly, if you got a results which is not one of the answer choice, and then you know how to get back, you can check your work rather than, oh, I start over again. That is a big waste of time, right? So it's important for you to show your forework. Check the annotations, obviously, right? If you find any bugs, please email me. I already, find about 10 bugs in the published work. So I will try to update them, after we finish this class. Hopefully I can get a little bit more. I will, publish a list in Google Classroom for you to know what are the bugs I already, realized. Okay. Do test corrections. That means, after you finish grading, you got 40, right? Think about out of the 40, there might be a few, you made a good guess, right? But that doesn't mean you fully understand the question. And for the other 20, obviously, solve them one by one. Check annotations, do some research, ask questions, email me, or I will make a Zoom chat after the class today. So if you have any question, feel free to raise your question there, okay? Secondly, students who participate in the class actively take notes, ask questions, review the contents, right? This definitely is important, right? Lastly, I would say this class definitely is not for everyone, right? You need to have a decent background. So I would say if you score 45 to 55 in the most recent locals, are ideal for this class. You'll be benefiting the most from this class. If you are score lower than 40 in the most recent local, probably this class might be too challenging for you. If you score higher than 55, you definitely can still get some, because you're already in the higher level. It's hard for you to further improve because sometimes there are some misconceptions, but you didn't realize, right? So in general, 45 to 55, I hope most of you are in this category. If you are not, just let me know, right? Okay. Oh, so lastly, the learning objectives I summarized. I spent a lot of time in summarizing those learning objectives. So I believe it would be helpful for you guys to prepare your national exams. So you can go to my website, teacher.us, find the learning objectives, or you can scan the QR code here. And I will post, a PDF documents in Google Classroom for you guys to check. If you want to print it and take notes and do some check marks, which one I need to do some further reading, which one I already have a good understanding. Okay, great guys. That is the brief introduction. Before we start the discussion today, do you have any other questions? Good. So guys, what I want to do is to talk about National 2021 Part 1. The reason why I chose this year is because, in my introduction, we have the stats of this year. I know not everyone finished this year before, so it's fine. For the non-computation based questions, you don't have to really prepare anything. For the computation-based questions, I will give you some time to briefly think about that, and then I will, show my work. You can try to, follow up and then ask the questions if you have. Okay. And if you think I'm too fast or too slow, just let me know. I want to get a speed which is suitable for most of you, right? For most of you, but the limitation is I don't know a lot of you too much, so we need to get some time to familiarize with each other, and then if I have a better understanding about your background, I think the class will be more efficient. Okay. So feel free to ask questions. Great. Number 1 to number 5, stoichiometries. I will just skip them unless you guys have any question. Okay, let's have a look at question number 6. You guys can take a look. Guys, if you finish this question before, I also want you to read it again and try it again, right? At least follow my work. Okay. First,
should we message you our answer?
Oh, you don't have to, because if you didn't do this question before, you probably need more time to work on it. If you solve it before, you probably remember the answer. So if I have a poll, you can share your answer. Okay. Okay. First, we know oxalic acid is a interesting. Give me a second. Good. Oxalic acid actually is a diprotic acid, right? I think we should know the structure of the oxalic acid. It is a carboxylic acid. There are 2 COOH groups, right? And this acid is a little bit special because typically we say a carboxylic acid with a COOH group cannot be oxidized. Cannot. So which means if you add some acidified potassium permanganate, there will be no reaction for the most regular carboxylic acid. But this one, I believe you all know, if you use the acidified permanganate, there is a reaction, right? What is the products of oxalic acid after the oxidation?
Sure, it's just like carbon dioxide or something.
It's carbon dioxide, right? So we can have a brief look of the oxidation number of the carbon in the oxalic acid. It's not hard for you to figure out. Both of these 2 carbons are +3. It might be easier for you to think from the molecular formula. But if you have a look at the structure, there are 3 CO bonds. When I say 3, is 3 single bonds, right? Because 1 double is counted as 2 single. So there are 3 CO bonds. This is why the carbon is +3. And this CC single bond is non-polar, which will not give the carbon a positive charge or a oxidation number, right? So obviously the +3 carbon is kind of relatively unstable, but this is not a key reason. The key reason why this reactants, this acid, this carboxylic acid is unstable is because both of these two carbons are positive charged, are partially positive charged, and now they are neighboring with each other. So which will make this carbon single bond, carbon-carbon single bond unstable and easy to decompose, right? So this is why it can be oxidized. And the other regular acid, this CC bond, you cannot break it, right? You cannot break it. So guys, although we are working on this question is a computation based, but I hope you guys can also take some notes, pay attention to the extended stuff, right? Okay, so we know this is a weak diprotic acid, by the way. I should say, most of the carboxylic acids are weak, most of them, right? Unless there are several super strong electron withdrawing groups, which can stabilize the conjugate base. So in general, we can simply conclude all carboxylic acids are weak, right? And then this is why the question asking you what is the percent of ionization. But as a diprotic acid, you all know the first step is dominant, the second step is negligible, right? We only need to care about. So how about we simple the reaction in this way, right? Is a weak acid, it dissociates into H plus and HA minus. How do we know how many percent is ionized? Obviously, we need to work on the number, right? The delta T, kind of the freezing point depression, right? This is the colligative property. I hope you guys all understand the background. If you don't know, please write down these keywords, colligative property, and do a little bit more research after class. So the general equation is delta TB or delta TF, the freezing point depression, equals to the KF, which is the freezing point depression constant, or you can say the molar freezing point depression. That is for 1 molar of solution, how many degrees does the freezing point decrease, right? This one times the molality, right? You guys know the definition of molality, right? So I think now, since we know the delta TF, we know the KF, we can figure out the molality. The molality equals to delta TF divided by KF, which is negative 1.31. We can use the absolute value, 1.31 degrees Celsius divided by 1.86 degrees Celsius. Because this small m, the lowercase of m means molar, right? The molar has a unit of mole per kilogram, and this kilogram is kilogram of solvent, right? So obviously we can figure out the molality, and now I think now you get a better sense because we know the mass of the solute, we know the mass of the solvent, right? So we should be able to get another molality, let's say called M0, which is 5.00 divided by 90.04. This is how many moles of solute, and then divided by 0.100 kilogram, right? This give you the mole. E. Seems like my pencil is not fully charged. Mole, right? You can get another number. So obviously, later if you check it, you will figure out M is greater than M0 because of the dissociation, right? Because of the dissociation. And then by comparing these two values, you should be able to figure out how many percent of the acid is ionized. Guys, does this make sense to you? Great. What do you feel? Do you think this is too fast or too slow, or is it okay for you?
It's okay for me.
Okay, thanks. So no news is good news, right? So there's no complaints. Okay.
I have a question. So
Yeah.
if how do we figure out the percent just by knowing like the molality, the relation in molality.
Let me give you an example. Okay. So
Okay.
if the M0, let me have a look. How many percent? Oh, it's 0% now. So I'm going to charge it for a while. Let's use my hands. So now say the M0 is 1, right? 1 mole per kilogram. And then the M calculated from the freezing point depression is 1.2. 1.2.
Mhm.
And then obviously a certain amount of the acid is dissociated, right?
Yes.
So you can use the rice table, which also called the ice box, because you have HA change into H plus and A minus. So the initial is 1, 0, 0. And at equilibrium, the 1 minus X, X, and X. So you know 1 minus X plus X equals to 1.2. So you can solve the X. After you solve the X, you know X divided by 1 will be the percentage of dissociation, right? And how many percent of the original acid is dissociated. Does this make sense to you?
So M0 is actually measuring the molality of A minus or
No, the molality of the acid, of the original acid, because you use the mass of the oxalic acid divided by the molar mass, further divided by the kilogram of the solvent. You get the molality of the original acid without considering any dissociation, right?
yes.
And M is the molality of the particles in the solution calculated from the freezing point depression, which includes the molecular form of the acid and also the ions. Because the character of colligative property is we do not care about what is the identity of the particles. We only care about the number of the particles. This is called colligative.
Okay.
It's number dependent. Did I answer your questions?
Yes. So that would be X over 1 equal 1 minus X over 1.2.
I would say it's X over 1, not X over 1.2, because X, the 1 is your original molality, right?
Oh, okay.
And X is how much it is dissociated, right?
Yeah.
Obviously, you need to use the real M and M0 to do the calculation, but the general idea is like this, right? So guys, I would say this question definitely is not easy. There are a bunch of stuff behind it, right? Behind it. So I will have a similar question in my mock test, right?
Okay.
Try it out later, okay? I will assign the mock exam after the class today.
All right.
Okay.
Dr. Chen,
Question. Yes.
I was just wondering, could you also solve it by using the I factor and then comparing the number you get from that into 3, because it would dissociate, or I guess 2 to H plus and HA minus, and then use that ratio to find the percent dissociation?
But the problem is you don't know what is the I factor, right? Without the calculation, because this is not a strong acid.
Okay.
If it's strong, you can say the I is 2, because 1 molecule of acid will directly change into 2 molecules of ions, right? I cannot say 2 molecules of ions. Let's say 1 mole of acid will change into 2 moles of ions, right? But here, since it's a weak acid, you don't know. Actually, you are calculating how many percent of the acid is dissociated by comparing the original molality with the calculated molality from the freezing point depression. Make sense?
Yeah, thank you.
Okay, no problem. Thank you. Okay, number 7, I want to briefly summarize. Can you give me a list of volumetric glassware? Volumetric means it can precisely measure the volume, right? Can you list a few?
I guess, can I start?
Yeah,
So, graduated cylinders.
graduate cylinder, good one. It's not the highest precision, but it's good because, for example, for a 100 milliliter of graduate cylinder, I think the smallest scale is 1 milliliter, right? The smallest scale is 1 milliliter. But for graduate cylinder, when it was designed, it was designed with a low precision. That means for graduate cylinder, you are not supposed to estimate one more digit. So that means for you either read it into 98 or 97 or 94, 95. You are not supposed to read it into 95 point something, right? This is the limitation of graduate cylinder. So this is also why graduate cylinders are cheaper, right? It's about $10, $15, $20 each. Compared to the more precise glassware, this is much cheaper.
Dr. Chen.
Yeah.
Pretty sure in a different place I heard how like graduated cylinders are plus or minus 0.1 milliliters, and then there are higher ones that can go to 0.01.
It depends. It depends. For example, for a 100 milliliter graduate cylinder, I would say typically the uncertainty is plus and minus 1 milliliter. But if you have a 10 milliliter graduate cylinder, it might be plus and minus 0.1. So typically, the uncertainty is in the same level with the smallest reading, the smallest mark, right? But for the other more precise glassware, typically you need to read one more digit. The uncertainty is 1/10 or 2/10 of the smallest mark. So can you give me a few more precise glassware? There are a few.
Volumetric pipettes.
That's a very good one, volumetric pipette. So when we say volumetric pipette, I also want you to compare with the graduated pipette. Do you know the difference of these two, volumetric and graduated pipette? Guys, if you don't know, because I didn't show you the picture, do some research now yourself, right? Search the two keywords in Google, you can quickly see that, right? So both are precise. Both should read into 0.00 milliliter. That means you should read to the second decimal. But the difference is graduated has a lot of marks, similar to the graduate cylinder, but is a more precise version. And volumetric pipettes has only one mark. It's either 10 or 20 or 5, depends on what is the volume you need. So that means it cannot measure any volume smaller than this or larger than this. It can only measure a certain volume, right? So typically, a graduated pipette is a little bit more expensive than a volumetric pipette because you need to add more marks. You need to calibrate all of the marks, make sure all of them are working and precise, right? Any other precise volumetric flask? Sorry, glassware, not volumetric flask.
Volumetric flask is one of them, though.
Volumetric flask is precise, but it's not used for transferring any solution. It's used to make a solution with a certain molarity, right? So that is a total different story.
So, but does that count really when you say glassware measuring?
I would say it's counted, but you understand, the application is different, right?
Yeah.
Can you give me one more?
Erlenmeyer flask.
Erlenmeyer flask. You know what is the Erlenmeyer flask, right? Erlenmeyer flask typically is just a regular flask, right? Or the conical flask. It has a shape like this, right? Like a shape like this, right?
Pretty sure they say on that the marks are only approximate.
Yeah, the marks are like this, and the water surface is huge, right? Which means if you do a slight different reading, the volume actually vary a lot. So this is not precise at all. We do not trust the reading here. So it's for approximation. It's for estimate. There's one more, actually, is in the list here, ABCD.
Burettes.
Yes, in the burette. Burette has also a high precision. It can read into the second decimal. Okay. So here, as you see, you need to read it into the second decimal. So the only answer, which can be accepted is C. Test tube, beakers, Erlenmeyer flask, they are not precise at all, right? So guys, I hope this can help you solve most of the similar questions, not only this question, okay? And take some time to do some reading and summary yourself.
So is burette like the most accurate, and then it's volumetric flask, and then it's the graduated pipette and graduated cylinder.
Not really. I would say burette have the same precision with volumetric pipette, graduated pipette.
Okay.
And actually, it's also a similar precision with the volumetric flask, although volumetric flask can be different because they have different size. The bigger one is like 1 liter, 2 liters, right? The smaller one is only 50 milliliters. So obviously, they have different precisions. But for burette, for graduated pipette, for volumetric pipette, their size are relatively fixed, right? Burette typically 50 milliliters. Graduated and volumetric pipette are typically 10 or 20 milliliters.
So volumetric graduated pipette and burette has like similar accuracy, which is very high.
Yeah.
Okay.
Second decimal.
Okay.
Okay. Guess I will skip 8. Let's have a look at number 9. For number 9, guys, if you didn't do this question before, I will ask you to have a poll. Give me a second. Based on this, I can also tell, how many of you practiced this question before and how well you understand the question, right? I also have a similar mock questions in my mock exam. Great. I think you guys have a very solid background. Okay, let's stop here. All of you got the same answer B, which is fantastic. So the reason why, first, let's talk about what is this precipitation produced in the system for B, iron 3 chloride.
Ion 3 hydroxide.
Iron 3 hydroxide, that's correct, right? How it is produced is the hydrolysis of iron 3 plus. Iron 3 plus want to bind the hydroxide from water, right? And change it to the iron 3 hydroxide. But at the same time, it will leave the H plus from water, and the H plus will bind with Cl minus, right? Will bind with Cl minus. So if the H plus is seen in the system, the H plus is supposed to dissolve the precipitate. But HCl is volatile. So when you open the bottle, some HCl will vaporize, right? And then the solution will produce more precipitate. And this process typically is irreversible. Once you have the precipitate produced, it's very hard for you to dissolve it back. HCl is gone and more precipitation. So this solution in the chemistry lab typically need to be replaced every several months because it's very hard to store. Guys, can you figure out a way we can prevent the precipitation?
Make it in acidic solution.
Exactly. Actually, this is how we prepare this solution. We'll dissolve the iron 3 chloride directly in a concentrated HCl. And then you have the H plus. The H plus can prevent, right? Can avoid the hydrolysis of iron 3 plus. So this question actually is related to the KSP of iron 3 hydroxide is very, very small. So this is why the Fe3 plus has a strong tendency to hydrolyze. Does this make sense to you guys? So at the same time, can we also go over the color of each ion here or each species here? A, permanganate.
Deep purple.
Yeah, deep purple, very good. B,
I'm pretty sure it's supposed to be blue.
B not blue. Iron 3 plus is yellowish.
I'm sorry. I looked at C, so
Okay, C, what is the color of C, Easton?
C is supposed to be blue because it's cobalt.
Is it blue? Is it aqueous solution? Right?
Pink, pink.
It's pink, right? It's pink. When it is blue?
Cobalt chloride.
Yes, when it complexed with the chloride and then it's blue, which means if you add some Cl minus in C, it will change from pink to blue, right? But D, I think you all know is blue, right? Is blue. Okay, good. Guys, how about we take a short break, right? This is our first class. Let's take a 5 minutes break. We'll restart around 9:30. Okay. See you guys in a few minutes.
Can I have a question? So what did you just said to turn blue?
Chloride.
When
When you add
cobalt,
chloride into the cobalt aqueous solution, the cobalt initially was binding with water to form the complex, and then it bind with chloride to change into a different complex, and the complex change into the color of blue.
okay.
Yeah, do a little bit more research about that. Okay, welcome back. Let's be ready to get started. I think my answer should work now. Great. Okay, the next question actually is iodometry, right? I don't think this is the first year for the USNCO to test iodometry. So iodometry, the general idea is we use iodine to titrate something which are strongly reducing. For example, here, vitamin C, right? Or ascorbic acid. You don't have to know exactly the structure of ascorbic acid, but you should have a sense ascorbic acid is a reducing agent. It is easily oxidized. That's they call it AA, okay? So after it react with I2, it will change into, I think it's called dihydroxy. No, I forgot the name. I think it's called DAA. So basically, there are several hydrogens which are gone from the structure of the ascorbic acid. And then the I2 change into I minus, right? The I2 change into I minus. This is the general idea. And we know any titration need to have an indicator, right? So for this reaction, the indicator is starch. Starch, you know, is a polysaccharide, right? This polysaccharide combined with I2 to form a dark blue complex. So which means in the beginning, when you put the vitamin C or the ascorbic acid in the flask, and you have the I2 solution in the burette, and then you add the starch to the vitamin C, right? And then you start to do the titration, and then you can see the endpoint will have a color change from colorless to blue. Does this make sense to you guys? Great. Guys, I have a question for you. So for this titration, should we put the vitamin C solution in the flask or in the burette? Or either way works?
I think it should be in the flask because I'm pretty sure that if you put it in the burette, then the indicator would not work.
If we put in the burette and then the I2 in the flask, and then if we add starch, in the beginning, it's blue. And then after you add enough vitamin C to consume all of the I2, theoretically, it will also change back into colorless. So the endpoint would be a different story, right? Although I understand your point, because when the I2 bind with the starch, typically, it takes a long time to fully take out the binded I2. So this is not ideal, as you mentioned. But this is not the most important reason. Actually, we have to put the vitamin C in the flask because your goal is to measure the amount of ascorbic acid in a vitamin C tablet. So you cannot put it into a burette. But you know, the burette has a structure like this. It's a long tube. And then there is a valve here, right? But you know, there are a lot of marks. But here, under a certain point, there's no mark anymore, which means there is some volume you don't know what is the exact amount, right? So which will affect your determination. You cannot figure out what is the amount of ascorbic acid in vitamin C, because when you add all of solution into the burette, right? Actually, not all of them are in your reading. Some of them are just, wasted or, consumed in the air bubbles or other places, right? Guys, this is critical. For questions like this in the USNCO, they will not directly tell you which one is in the burette, which one is in the flask. They will typically say, I use something to titrate against another thing, right? You need to have a clear idea. What is the practical, situation, right? For this one, because you rely on the mass of the vitamin C tablet, so you have to fully dissolve this measured tablet and fully dissolve into the flask, right? And then titrate all of them. Does this make sense to you?
So can I say that vitamin C is in the flask because we want to determine the amount of vitamin C, but not the amount of I2?
You're right. That means
Okay.
for the I2, it's supposed to be a standardized solution. We are supposed to
Okay.
know the molarity of I2, right?
Yeah.
Otherwise, you cannot do the calculation, right? Guys, you understand why iodine is always, mixed with potassium iodide, right? Because two reasons. First, I2 is toxic. Its vapor is toxic, right?
Okay.
So in order to lower down the volatility, we add some I minus to change it into I3 minus. Secondly, I2 is nonpolar. It has a limited solubility in water. So adding I minus will change the I2 into an ionic, species, which has a much higher solubility in water. Does this make sense to you? But you still, even you change it into I3 minus still work in the same way with I2 because you can see there is one I2 in each of the I3 minus, right?
So when it binds to starch, is it the I3 minus that binds or the I2 that binds?
It is still the I2, but the I3 minus can release into I2. So I3 minus can also make the starch change color because there is an equilibrium, right?
Oh,
Great, good question. Okay, guys, can you list a few other species which can be directly oxidized by I2? Similar to the ascorbic acid. At least one more, at least one more. This was assessed in the USNCO before.
is that the steel sulfate or?
Yes, the thiosulfate is another one, right? Actually, this solution is also used to standardize the I2 solution, right? Because this is a primary standard. If we need to list a few more, we can say SO2, we can say sulfite, we can say bisulfite, stuff like that. Those are all able to be oxidized by I2 directly. Guys, all of those directly using I2 to oxidize something is called direct iodometry. So next time I will further extend to talk about the indirect iodometry. So let's do it step by step, okay? So what is the correct answer? I believe it's A, right? It forms a intensively colored complex and the color is dark blue. Sometimes it's just like black because it's very dark. Good, guys. For question number 11, I would like to temporarily skip it and we'll go back later, okay? But I want you guys to do some reading about crystal field theory before our discussion. So you need to have some fundamental idea about crystal field theory, because actually this is how we explain these two ions have different color. The left one, as we mentioned, is pink, right? The right one has blue. They have a different ligand, chloride and water, right? So using the crystal field theory can explain you why they have different color, right? So I think it's easy for you to find some useful, reading material. If you cannot find, let me know. I can share some links in Google Classroom, okay? Let's have a look at question number 12. Let's take a minute to read it. I think you finished reading the question, right? this is what I drew here is a typical spectrum, right? Absorption spectrum, right? The x-axis is the wavelength. Typically, it's from 400 nanometer to 700 nanometer because this is the visible range. And then the y-axis is the absorbance, the ABS, right? So now we choose the lambda max, which is the maximum absorbance, right? And then we use Beer's law. Guys, let me ask you a question. If I do not use the lambda max, let's say I use this lambda, is the absorption still proportional to the molarity? Does it still follow the Beer's law?
Yeah.
Yeah.
The answer is yes. Theoretically, you can choose any wavelength, but typically we'll choose the lambda max because it's the most sensitive. Right? If you choose a very small one, all of the absorbance will be very small, right? And then the sensitivity will be lower. But ideally, they all follow the Beer's law, right? Okay, let's read the ABCD one by one. A, the cuvette is now rinsed with soft solution after being washed. You guys know, after we wash the cuvette with water, there is always some water residue remained in the cuvette, right? So if you directly add the soft solution in the cuvette, your solution actually diluted, right? And then your results will be lower. Does this make sense to you? So how to avoid this? We will use the salt solution to rinse the cuvette for several times, 2 to 3 times. So we can minimize dilution factor, right? Because basically we kind of remove all of the water, right? No problem. B, the cuvette is not wiped off before it is inserted into the spectrophotometer. So which means on the external wall of the cuvette, there might be some soft solution, right? Then how does this affect your results?
Since there's more salt solution, I think it might actually be so basically the salt solution on the outside increases the increases the size of the cuvette theoretically.
Okay, I got you. So increase the light path, right? Yeah, that's called the light path length or the light path. Yeah, so it will increase the absorbance and then it will overestimate the concentration, right? For C, less than the recommended volume of the salt solution is added to the cuvette. That means, now say if the cuvette is like this, so if the recommended, volume is this much and you add this much, the light probably didn't pass through the solution, you get a 0 absorbance, right? So this might give you a 0 value, obviously it's not right. For D, the spectrometer is set to a wavelength different from lambda max. That means if we choose this wavelength, right, and then you still use the same calibration curve. So in the Beer's law, absorbance equals to epsilon is constant times light path times the molarity. So this epsilon will be larger in the lambda max, will be smaller for a different wavelength. So you get a smaller absorbance, but you still use the larger version of the constant. Obviously, you get a smaller molarity, right? Does this make sense to you? Guys, another commonly asked question is, if on the cuvette there is some fingerprint I didn't wipe off, how does this affect your absorbance?
Increases absorbance.
The fingerprint typically is the oil, right? Which will block or absorb the light, increasing the absorbance. Does this make sense to you? Great.
Isn't that a similar situation for choice B here? The fingerprint.
Yeah.
Okay.
Yeah, but it works in a slightly different mechanism, right? Because
Okay.
fingerprint typically block the light, and then some salt solution which are not wiped off will absorb the light. Okay, guys. So we talk about the 6, descriptive and the laboratory. Limited by the time today, I want you to also have a taste of the calculation questions. So I want to go over with you some electrochemistry. Let's jump to 37, right? The first question is about balance of a redox reaction, right? This is the disproportionation of chlorine, Cl2 change into Cl minus and ClO3 minus. As you obviously you can have different ways to solve the problem. You can use half reactions, but if you want to be a little bit faster, I would like to introduce my method. So the general idea is like this: you show how the oxidation number change of each element. Down arrow means it's getting lower, up arrow getting higher, and you write down the oxidation number change as a subscript. And then you can clearly see in order to balance it, right? When we say balancing, we need to balance the oxidation number change because the oxidation number change is a reflection of the electron transfer, right? So we need to put a 5 here, we need to put a 1 here. Does this make sense too? What is called in math? Minimum common multiple, right?
Multiple.
Okay. So, and then you know, based on the conservation of chlorine, you should have 3 chlorine gas in the left side. And now is your time to consider the charge. The charge is the next step immediately after you balance the oxidation numbers. So in the right side, you have 8 anions, right? Or 8 negative charges. And in the left side, you also need to have 6 negative charges. So since this is the basic solution, right? You add 6 hydroxide in the left. Does this make sense to you guys? Okay. And then we add 3 water in the right side to balance the hydrogen. Finally, you check the number of oxygens in both sides. 6 equals to 3 plus 3. No problem, right? Okay, guys. May I give you one practice quickly? Try to finish the balancing in 30 seconds to 1 minute. The reaction is about the reaction between copper with concentrated nitric acid. If you finish, you can type the coefficient of water in the chat box to me. You can share with me only, or you can share with everyone. Obviously, we want to make all of the coefficient the smallest integer. Great. A lot of you already got it, right? Let me quickly show my work. If you're still working, you can have a look. Do you agree with my 1, 2, 1, 2 here, right? This is the first step. And then you check the 2 sides. Left side, you have 2 negative charge. Right side, you have 2 positive charge. We didn't consider the H plus here, right? So in order to balance the charges, we need to put a 4 here, right? And then in order to balance the hydrogen, you put a 2 here. Finally, you check the number of oxygens, right? In the left, 6. In the right, 4 plus 2, 6. Good, well done, right? Guys, pay attention to the media, right? Sometimes if the solution is basic, you cannot add H plus in the left side, okay? So the worst case is you add H plus in the left, and then you add hydroxide in the right. This is not acceptable, but this is very common. I commonly saw mistakes from my students like this. Okay, guys, let's have a look at the next one. The oxidation states of the sulfur in thiosulfate. Guys, typically we only care about the average oxidation number, right? That is easy for you to calculate, which is +2. But now the question, if you go over the A, B, C, D, you will see they want to differentiate, right? The 2 sulfurs. Are they both 2, or it's just the average is 2, right? So you may need to have a look at the structure. So let me give you an easy question for you to think. Uh-oh. Can you let me know what is the oxidation number of carbon in cyanide, Cn minus? What is the oxidation number of carbon? Because the oxidation number, although it's assigned by us, but it should have a certain reason, right?
It's +2.
+2. Yeah, I saw some +2 from TNE, from Eastern. Let's have a look at the structure. Cn minus, if you draw the Lewis structure, is not hard for you to figure out. It's like this, right? There's a triple bond. Because Cn minus is isoelectronic to nitrogen gas, right? So there's a triple bond. So which means the nitrogen has a triple bond to carbon, and we know nitrogen is more electronegative than carbon, right? So nitrogen would be -3. Because when we assign oxidation number, we assume the charge is completely goes to the side which is the more electronegative. For example, HCl, we know this is a covalent bond, but we assign the chlorine -1, although actually it's only partially negative, right? But we assume this shared electron pair completely goes to chlorine. This is how we assign oxidation number, because we want to have the integer. We don't want to have the partial charge. So then you know this one is +2, right? So +2 is correct. So how to figure it's +2? From the triple bond, it's +3. And then there's a negative charge. Partially cancel the +3, change into +2. Does this make sense to you? So I think this is the fundamental for you to further think about the thiosulfate. Thiosulfate, the structure, I hope is not hard for you to figure out. The structure, the connection is like this, because a sulfur atom replaces an oxygen atom in the sulfate. So this is why it is called thiosulfate, right? And now you want to draw the Lewis structure, right? So let's try. You want to make the O double bonded, right? But if you make all of them double bonded, all of the terminal atoms are happy. But now the central sulfur shows 8 valence electrons. So it will carry a -2 charges. So this is a correct structure, but it's not the best one considering the formal charge, right? Because we want to minimize the formal charge. At least do not put two negative formal charge on a single atom, right? So you can draw a few more better resonance structures. So we just need to change 2 of the double bond into single bond. Guess I didn't show the lone pairs of other atoms. You understand what I mean, right? So this is one of them. Obviously, you can put the double bond in different positions, right? And there should be several resonances. So if we follow this one, it's not hard for you to figure out. The central sulfur will be plus. In this structure, the central sulfur will be plus 5, right? Will be +5, because you see it has 5 SO bonds. If we think the SS bond is nonpolar, then the SS bond will not give sulfur a charge, right? So it's +5 here. How about this sulfur here? It will be -1, right? Because this bond is nonpolar, it carry a negative charge. So this is somehow similar to hydrogen peroxide. -1, -1. Where is -1 from? This is nonpolar bond. This bond will make oxygen -1. This bond will make oxygen -1. Makes sense, right? But if you, yeah.
Can you talk about again why the middle one is +5?
Because you see, there is one SS nonpolar bond. There are 5 SO polar bonds, right?
Yes.
And oxygen is more electronegative than sulfur. Then the sulfur.
Oh, okay. Yeah, I see. Okay.
Great. So, but if we draw a different resonance structure like this, you probably will quickly figure out this sulfur change into +4, this sulfur change into 0, right? But obviously, if you go over the A, B, C, D, we only have the +5 and the -1. We don't have the +4 and 0. So based on this, I think it's good enough for you to pick up C, right? At least it matches with one of the resonance structures. But the problem is this answer really reasonable? Is this the major resonance structure? Is this one more stable than this one? Typically, we say we want to put the negative charge on the more electronegative atom, right? That is typically the story, right? So it seems like the left one should be more stable with a higher contribution, right? So this is somehow a little bit debatable, but you can also realize, S double bond actually is very unstable due to the uniqueness of the second period elements. The third period elements, or even the below element, they do not want to make multiple bonds because their size are too big. So the PP overlapping in this direction is very limited, right? So as a double bond is much weaker. So I would say it's still reasonable for us to say this one had a significant contribution to the real structure. So it's not too bad for us to conclude C is reasonable, right? Guys, I have a similar question for you to try in my mock exam, okay? 39, I think, is not a hard question. Faraday's law, I don't want to spend too much time here, but there's only one thing I want to briefly talk about. I think this is the first time for us to have a new concept of the yield. Why there's a yield, right? Guys, all of the electrolysis questions we solved before are ideal. We are assuming 100% of the electricity is used to produce what you want, right? But actually, this is not the real case. Some electricity is lost due to the production of heat. We will definitely want to minimize that. For example, if you use a laptop, if your lithium-ion battery is producing heat, then it's a bomb, right? You don't want to have that. But it will happen because this is why, when you're using it for a while, you feel, wow, it's getting hot, right? Although now it seems like, leading by Apple, they are making, their chips less energy consumption, right? But it happens. And also, it might produce some side products, which is not the product you want. So you have you have a percent here, right? Guys, I will leave this question for you to do after class, okay? And then some regular 40, I think is a regular question, right? Pretty much assessed it every year. Basically, is use, the electrochemical method to calculate the KSP, right? Guys, I don't know how, what's your background about this, but I'll quickly show my work. If you have a question, let me know after class. I can further explain, okay? So there are two methods. I definitely recommend the first method. So we can use these two half reactions to make an overall reaction. But the interesting story is we use this one as the cathode, use this one as the anode. Anode is oxidation, cathode the reduction, no problem, right? That means the first reaction actually is flipped. So AgI plus electron change into Ag plus I minus. The first one will flip it, Ag change into Ag plus electron, and then you add these two half reactions together, you will see the Ag and Ag are cancelled, electrons are cancelled. You got AgI change into Ag plus and I minus. This is exactly what you need for KSP, right? So interesting story is we use two half reactions, get a non-redox reaction. This is the magic of measurement of the KSP by using electrochemical method, right? Then you see the E cell standard of this reaction still equals to E cathode minus E anode. And since the second one is cathode, the first one is anode, obviously you get a negative results. And it's reasonable to be negative because obviously this reaction is not spontaneous, right? The Ksp is very small. And then you use the E, you can get the delta G standard by using negative NFE standard cell, right? And then using this, you can further get it equals to negative RT ln K, and this K is Ksp. So finally, by calculating the E cell standard, you figure out the Ksp, right? This is the first method, the standard method. Guess I will talk about my second method next time when we see a similar question in the other years of nationals, okay? You're good with this? Great. 41, I will say, is one of the most difficult question in this year. I need to make it, how about we make it this size, and then you can see the contents. Right? Guess I will give you 1 minute for you to read it. We try to finish the class at around 10:10 today, okay?
Do we need to make a choice or
No.
just
I think we can try if you know you didn't do this question before.
okay.
So guys, you cannot see option D because I don't want to make it too small. But what you can what you can expect is in D the water level is different, right? Is the right side is higher, the left side is lower. I hope you understand the story here. First, why the two sides might have a different water level, right? Obviously, B for sure is incorrect, right? You can eliminate. There's no water coming from, right? There's no reason. I saw a lot of you got the correct answer, but I'm really interested about what's your understanding. Is there anyone who volunteered to briefly explain, justify your answer? Go ahead.
So
Oh.
the left,
Go ahead. Go ahead.
okay, so the left side is zinc, which is like more reactive than copper, so it's more likely to lose the electron.
Very
so that
good.
way it produces more ions. So it will do from Zn to Zn2 plus and 2 electrons. So there's more ions, so the water tends to go to a place that has more stuff, so it just rises on the left.
I see. That's a good point. Because I have a further question to check with you. Do you need to consider the ions input from the salt bridge? Because you know the bridge is to make up, you know, the unbalancing of the charges, right? That means when you add zinc 2 plus to the left side, some nitrate will also coming out from the salt bridge. In the right side, when you are losing some copper 2 plus, some sodium plus will be added to the right side, right?
I'm pretty sure
This give you a different answer.
That's going to contribute to ions, but since like the zinc side is going to have more ions, so more ions will come from the salt ridge versus the other side that has less. So
Okay.
it's going to like make the same results.
Let's have a look. So now say in the left side, we add 1 mole zinc 2 plus. Then we'll add 2 mole of nitrate. So in general, the left side will have 3 moles of ions increased, right? In the right side, we have 1 mole of copper 2 plus, which is gone, right? Which is gone, minus 1 mole of copper 2 plus. At the same time, we add 2 moles of nitrates, right? Does this make sense to you? Then the overall change is +1, but the overall change here is +3. So both sides will have more ions if we even consider the ions from the salt bridge, right? But still, the left side will have more ions, which means it should have the water will go through the right side to the left side, right? For the right side, the goal when we stop the water flow is when these two sides have the same molarity of ions, total ions, right? But obviously this is impossible, right? So this is why when some water flow from the right side to the left side, it will produce a pressure and prevent the flow of the water from the right to the left. Does this make sense to you? It will stop at a certain point, right? It will reach equilibrium. Okay, this is an interesting question, right? It's a pretty new question. Yeah, go ahead, Ryan.
Yeah, I'm good.
Okay, great. So it's not a computation question, but I will say this is how national exam are harder because you will see a bunch of new questions like this. You need to really think about the process, right? This is a combination of electrochemistry with colligative property, the osmotic pressure, right? Although we didn't show the concept here. Okay, 42. Let's try to finish this last question today. It's a pretty time-consuming and complicated electrochemistry question. You can also take a minute to read it. Okay, there's a concept. The cell is fully discharged. Then it gives you a good hint, the delta E. Guys, to be honest, here in the USNCO, typically we don't use delta E. We use E cell standard, right? Because the E cell standard is a difference of the cathode and the anode, is a delta, right? But typically we do not use delta, but you understand what is the meaning of delta here, right? So delta E standard or E cell standard is when this one is 1 molar, this one is 1 molar. What is the potential difference, right? But the delta is at any state. It can be non-standard state. So when the cell is fully discharged, that means the reaction is at equilibrium state. The delta E is 0. The delta G is also 0, right? And then at this moment, the final mass of the chromium changed from 20 to 24.0, right? Increased by 4.5 grams, sorry, 4.50 grams, right? Which means the reaction goes to the right side, right? We change Cl3 plus into chromium. I think this is a perfect example of Nernst equation because E cell equals to E cell standard, right? Minus RT over NF ln Q, right? If you watched my open class, I personally recommend you use this equation, 0.0591 divided by N log Q. So basically we combine a bunch of constant and we also change the natural logarithm into the logarithm with a base of 10. And then we got a combined constant, 0.0591. Because N is variable, so we leave the N here, right? So then the question is asking you, what is the E cell standard? And we already know the E cell is 0 when the cell is fully discharged. So if we can figure out what is the Q, then we are able to get the E cell standard, right? So how can we get the Q? We need to know the molarity of Cl3 plus when it's fully discharged. We need to know the molarity of zinc 2 plus when it's fully charged, right? So obviously for the Cr3 plus is not hard because Cr3 plus equals to 0.10 molar and minus, right? What is the volume? 1 liter, right? So I think let's show the forward. the initial moles, 0.1 times 1.0 liter minus the subtracted part, because the mass of the metal is increased by 4.50 gram, right? For chromium, what is the molar mass, guys? 52.00?
Yeah, 51.99, but 52.
Thank you. Okay, so I will skip the unit. 4.5 divided by 52.0. This is how many moles of Cr is gone, and then we divide it by the new volume. So I think we can suppose the volume doesn't change, right? So we can figure out what is the new molarity. This is the new molarity of Cr3 plus at equilibrium state. Guys, do we have an easy way, or do we have a way to figure out what is the new molarity of zinc 2 plus? Obviously, the zinc 2 plus will increase, right? Because some zinc will change into zinc 2 plus, right? But do we know what is the mass of zinc change into zinc 2 plus? Actually, we know. There is a ratio, right? There is a ratio. This is the moles of the Cr. There is a relationship between the Cr produced with the zinc produced, right? There is a 2:3 ratio, right? So I will say it will be 0.10 times 1.0 liter plus this box. This box is from here times 3 divided by 2. Does this make sense to you? And then divided by 1.0 liter. After you figure out this and this, the question is easier, right? Because the Q equals to zinc 2 plus cubic divided by Cr3 plus squared, right? And then you substitute this Q back into the original equation. You can figure out the E cell standard, right? Guys, I will leave the math work for you to do after class. So we sort the method. Yeah.
I have a question. So why is it 0.1 molarity instead of 1 molarity?
Originally it's 0.1, right?
Yeah, so okay, got it. Oh.
Yeah. Guys, I would say this is definitely not an easy question if this is the first time for you to solve a question like this. Thinking about the method is not that straightforward, and solving the math work is also relatively time consuming, and it's also easy to make mistakes, right? Guys, can you think about, one mistake you might make is you don't know how to do it, right? You have no idea. Are there any other, silly mistakes you might make?
You didn't put the cube and the square on the cube?
Oh, you mean you forgot the ratio here?
Yes.
The power, right? The coefficient as power. I think that's possible, right?
Yeah,
Maybe
that's
you
A. I just
got your
did
N
that.
wrong.
What did you say, Eastern?
Maybe you got your N wrong.
All the number of electrons. What is the N here?
6.
It's 6, right? It's 6. And another mistake you might make, you simply think the moles of the change are the same, right? You didn't times the 3/2, right? Stuff like that, right? You might make different mistakes. I also have a mock question for this one, right? Try it out. You can, have a look at, my level of making mock exams. Okay, great, guys. I think I will encourage you guys to finish this year before you work on my mock exam. The mock exam is recommended for 15 minutes, and I hope you guys can make it done before our class tomorrow. So that means if you can finish by 8:30 p.m. tomorrow Eastern time, that would be wonderful. I can see your results, and we can, discuss based on your results. But that means you should finish the National 2021 first. We already finished, about 12 or 18 of them if we include the stoichiometry, right? So you can, take probably another 70 minutes or 75 minutes to work on the others. For those we already discussed, please still work on it to get the answer, okay? Especially its computation. The organic this year, if you work on it, you will feel it's pretty challenging. It's much harder than the local exam. It's a totally different level of organic chemistry, right? I would say in general for organic, there are maybe only one easy question and maybe 2 medium question, but all of the others are hard in this year at least. Right? So you see the trends. Organic chemistry is getting a little bit crazy, but compared to the chemistry competition in the other countries, I still think the USNCO had a relatively lower requirement for organic chemistry. But you see the trends is getting changed. Right? So work on this and read the annotations. And tomorrow I will compare the original question with the mock questions I made, and then I will explain both. Right? So please take some time if you have to work on the 2021 part 1 and my mock. I will assign the link in Google Classroom later today. Guys, that's pretty much our first class today. I hope it worked out for most of you guys. Not too fast, not too slow, and feel free to let me know what you think. Okay. If you have any questions, feel free to stay for a while. Otherwise, I will see you guys tomorrow.
Right.
Dr. Chen.
Yeah.
So when we do the form, will we be able to see our results as soon as we submit?
You will see your final results, like how many you got correct, how many got wrong, which one you got wrong.
Yeah. Okay.
Yeah. Okay, feel free to go if you don't have any questions. Thank you,
Are
everyone.
we allowed to use the notes for the mock exam or no?
I will say you do better not, right? You do better not try to memorize any answer, and you do better not, use any external resources.
Okay.
Just, mark yourself, test yourself.
Okay, got it.
Yeah.
Dr. Chen, sorry, quick question. Could you post the recording of this session in Google Classroom afterwards?
Sure, I will do that.
Okay, thank you so much. Have a
No
good night.
problem. Yeah, you too. See you tomorrow. Okay, so I'm assuming you guys have no question, right?
I have a really quick question.
Okay, go ahead.
Okay, so can you go back to number 6?
Yeah.
Yeah. So would it be like a valid approach to just use the standard freezing point depression formula, like delta T equals I times K times molality? But then, so you can use the original, like you can calculate the molality from the given information, and then you're given the constant. So then you can just find the Van Hoff factor. And then like I did that and I got 1.268, which is B. Yeah, is that like a valid approach?
I feel it's the same idea. But let me double check. So you get an I of 1.268, right?
Yeah.
If you gotta use that -1, it'll give you B. I think B is the correct answer, right?
Yeah.
But I'm thinking, though the reason why it works in this way with your method is because this is a 1 particle turned into 2 particles, right? If this is a 1 particle turned into 3 particles, or I don't know, does this still work?
My thinking is like if you have an ion that produces 2 particles, the Van Hoff is 2. So like if you have like oxalic acid and you get 1.26, that means for every 1 like mole of the acid you put in, you get 1.26 particles. So like 26% of it disassociates.
Yeah, I think that still goes back to is 1 minus x plus x plus x equals to your Van Hoff factor, right?
Yeah.
So that is how you get the x. And if it's not this scenario, I think you cannot directly use the calculate the Van Hoff factor to -1 to get the percent of ionization, right?
Okay, yeah.
Yeah, I think your method definitely works, at least in this scenario. But I think the method I used is also easy to understand, right? It's
Yeah,
basically based on the icebox, okay? So it's more original, method, less fancy.
Yeah.
Okay. Alex, you have a question?
Yeah, so for number 41, we said like the ions would move from right to left.
Not the ions, the water will move from the right to left because this semi-permeable membrane only allows the water to pass, right?
Oh, okay.
Yeah. So it's because the left side has more ions, so the right side will have a higher water potential. So the water will flow from the higher water potential to the left one, right?
Yeah.
And then later, when the water is accumulated, it will prevent the further water flow from right to left.
Okay.
Mhm.
If they said that if like the ions could also move and then the copper mass increases on the right side, wouldn't that also increase the water level because now there's like more solid, so it increases the water level?
First, the semi-permeable membrane only allows water to flow. Secondly, the copper 2 plus actually decreases in the right side, right?
Yeah, but it increases the mass of the solid that's like in the water.
But that doesn't work. The solid doesn't, affect the water potential or the osmotic pressure in any side.
Okay.
Yeah. Okay, thanks for your question. No more? We're good? Great.
老师我就不用做那个，对吧？
你不用做了吧
OK，
？OK。